Hi guys, welcome back. In this and the next two videos, we'll see how we can declare and use Python's rich built-in data types. Of course, there are all kinds of custom data types created by developers like you and me. All custom data types are built on Python's built-in data types. First, let's look at numbers. In Python, numbers include integers and real numbers. Integers in Python can be used to do the usual calculations such as addition, subtraction, multiplication, division, modulo, power operations, and more. Let's use Python's interactive shell to do some calculations. Okay, let's fire up idle, which will start the interactive Python shell by default. Here, I declare a variable a and initialize it to 20, and another variable b and initialize it to 7. So as you can see here, the results of a plus b, a minus b, a multiplied by b, just quite straightforward. But in the case of division, we need to pay attention to two things. First, in Python programming, as in all other programming languages, division by 0 is an error. And this is not right in math either, okay? For example, a divided by 0 will cause the interactive shell to throw this error message: 0 division error, division by 0. And secondly, in Python, there are actually two kinds of division. One is the real division in the case of a divided by b, that is 20 divided by 7. You can see the result is not an integer, but a decimal number. By the way, you may see this hashtag, and everything after the hashtag is a comment, which is ignored by the Python interpreter by default. So they will not be run, okay? And the other kind of division is the so-called integer division, like a integer divided by b. The result of this division is an integer rounded down to the smallest integer possible. Here you can see that the result of a integer divided by b, that is 20 integer divided by 7, is 2 instead of 3. It seems that the result is rounded down instead of up. With negative numbers, it is the same, just like minus a integer divided by b, that is minus 20 integer divided by 7, will produce minus 3 instead of minus 2. So if we want to truncate a real number, we can use Python's built-in int function. For example, we just feed the int function this decimal number, and it will produce only the integer parts, and the decimal parts is ignored, is truncated. And how about a minus decimal number? We only just get the minus integer parts, like minus 2. So that means the function truncates towards 0. Next, let's look at the modulo operation, which produces the remainder of a division operation, like a modulo b, that is 20 modulo 7, we'll get, you guess right, 6. And the last integer operation in Python we'll talk about is the power operation, like 3 powered by 3. So this is just like 3 multiplied by 3 and multiplied by 3. That's 3 cubed. We got 27. So here, the two asterisks here are the power operator, and 3 on the left is the base number. And this 3 on its right is the exponent. We can have another example like 3 powered by 4. You got 81. So how about when the exponent is negative, just like 10 powered by -2? That is 1 above 10 powered by +2. That's 0.01. And 3 powered by 10 powered by -3, which equals just like 1 above 10 powered by +3, because you're right, 0.001. Note that the exponents can be a decimal number too, like 100 powered by 0.5. That is the square root of 100, which is 10. But please notice that when the exponent is a decimal number like 0.5, the result will also be a decimal number, although the decimal parts can be 0 in this case. And in Python, there is an alternative to the power operator. That is the built-in pow function. Okay. One version of the pow function takes 2 arguments. The first is the base number, and the second is the exponent. Like, okay, base number 2, exponent 4. So here you can see the Python interactive shell just provides the prototype for this function. Okay, as you can see here. So that is like 2 powered by 4. You can see it will produce 16. And in the case of 2 powered by -4, that is 2 powered by -4, will produce 0.0625. So you can see when the exponent is a decimal, the power function will produce a decimal result, like pow 10,000, 0.25. That is 10,000 powered by 0.25. You got 10. Okay. Next, let's turn to real numbers like 4.5, 6.3. Okay, you can see these are called floating point numbers. Almost all the above operations on integers can be done on real numbers too. You may want to test out by yourself in the interactive Python shell. What we need to note is that in Python, as well as in many other programming languages, floating point numbers are only close approximate representations. For example, 3.2 minus 1.5. You may think the result is needs 1.7, right? But as you can see here, we have a very long decimal parts, okay, which is close enough to 1.7. So when writing code, just remember to test the results of operations involving real numbers. And in Python 3.6 and later, you can even write a number in such a funny way, like, for example, n equals sign 1 underscore 3 zeros, another underscore 3 zeros. So this is just like 1 million. Or you can just also use this kind of formats with real numbers as well. For example, p equals sign 3, 6, 5. So this will just be equal to this. Okay, let's show the results, right? And for p, it's just these results, okay. And in Python, there are many other number types like complex numbers and fractions. If you're interested, you may check them out in Python documentation on Python's website. The web address can be found in the comment area. I know math is boring, but if you have been with me up to this moment, you are great. Let's turn to something that is different from ordinary numbers. This is the Boolean type. In Python, the two keywords, true and false, are used to represent truth values. You can use the so-called logical operators to produce truth values. For example, true and false will produce false. Okay, this AND is a logical operator, and it produces the results of combining the value on its left with that on its right. So for true and false, the result will be false because one of the operands is false. How about true or false? The result will be true because for or, if either value is true, it will produce the true as a result. And we also got not true. That's the negation of the operand. So for not, we only have got one operand. So you got false. For not false, that's just the opposite. That will produce true. So in Python, all expressions can be evaluated to either true or false, like 3 equals 5. So for double equal sign, it means testing out whether the value on its left is equal to that on its right. 3 does not equal 5, so the result will be false. How about 5 equals 5? It will produce true. And another example would be 3 is less than 5. It will produce true. And if it is 2 is greater than 4, it will produce false. Okay. And we also use Python's built-in bool function. Okay, we can just feed it any value like 3. This will produce true. And for bool -8, -3, it will produce true as well. Not because it's a minus number. So when will bool produce false, the only value that makes bool produce false is 0 or none. None is a value. That means there is no value. And none is also one of the keywords in Python. Okay, so it produces also false. Okay. And the Boolean type is also used to test whether a string contains a certain character, like hello, find E equals or greater than 0. Will this produce true or false? Here, hello is a string, and find is the method that belongs to the string class that is used to find whether a character is within the string before it. Okay, let's see. This will produce true because the character E is in hello. How about hello, find G? Would be false. These expressions are often used with conditional expressions such as if and while, which we'll deal with soon in one of our later videos. Okay, we have talked all about numbers in this video. In our next video, we'll talk about Python strings, byte arrays, and tuples. Thanks for watching. If you like my video, please give me a like and subscribe my video. Talk to you later in our next video. Bye.